Welcome back, class. Welcome in lecture number 4 of your organic chemistry. And in this lecture, we are going to discuss about the some different nucleophilic substitution reaction. We had already discussed nucleophilic substitution reaction SN1 and SN2, but there are other nucleophilic substitution reactions. So we can say that the examples or other types of nucleophilic substitution reaction. So nucleophilic substitution reaction. Okay, these are some other examples. In this video we are going to discuss some other examples of nucleophilic substitution reaction. Okay, so let's start with the first reaction, and that is substitution by hydroxyl group. Substitution by hydroxyl group. Hydroxyl group means what? OH, hydroxyl group. And with this substitution, what we will get? We will get alcohol. So here I am writing formation of alcohol. So by substituting the hydroxyl group, what we'll get? We get the alcohol. So let's take the example. Here I am writing the general equation. The general equation is what? You have alkyl halide Rx, okay, and then we have what hydroxyl group. So we can take example of KOH. K is positive charge, OH is negative charge. Here this one is the positive, this one is the negative. Okay, so this is easily formed, and while simple heating, what will get? We get ROH. So formation of alcohol with KX. So if you take any example, let's take an example of CH3CH2 Br, then KOH. This KOH, here I am writing AQ means aqueous. KOH can be used in two types. One is in aqueous form, other one is the alcoholic form. This I will discuss in next video when we will talk about the elimination reaction. So this I will discuss what is the role of aqueous and what is the role of alcoholic KOH. Okay, so what we'll get? We get CH3CH2OH and KBr. So this is very simple reaction. Now moving ahead, the second reaction. The second is substitution by alkoxy group. Substitution by alkoxy group. Okay, so substitution by alkoxy groups, what it will give? It will give ether. So we'll get formation of ether. Okay, so by the substitution of alkoxy group we'll get ether. Okay, so let's take an example of this. So let's write the general equation first. So again we have Rx and then alkoxy. So we'll take example of sodium alkoxide. So here I'm writing NaOR, Na plus. Okay, so this is sodium alkoxide. So this alkoxide will give you this again very simple reaction ROR. So this is what? Ether and NaX. So let's talk about an example. If you can take CH3CH2 Br again, and then we have Na plus, O minus, and C2H, C2H5. So O2 minus, so this will be a plus charge. Okay, and by simple heating, what will we get? We get CH3, CH2O, C2H5 plus NaBr. So the name, the name of this reaction is Williamson synthesis. The name of this reaction is what? Williamson synthesis. So this is a name reaction. Okay, so this is very important. Okay, moving ahead, let's discuss some more example of such kind of reaction. So let's talk about uh, substitution by amino group. So third reaction, substitution by amino group. So while we'll substitute the amino group, what we'll get? We'll get amine. So here I'm writing formation of what? Amines. Okay, so this is the third reaction. Substitution by amino group will give you amine. Okay, so let's start. Very first is the general equation. The general equation says that we have Rx, then substitution by amino group, so required amino group, so this we can write here. So this is ammonia NH3. I'm writing in this pattern. Okay, then again this is simple, it will eliminate, substitute, so we'll get what? We'll get RNH2. This is the amine plus HX. Okay, let's take example of this reaction. Again we have a CH3 CH2 Br plus HNH2. Okay, HNH2. So what we'll get? We will get CH3 CH2, and this will remove, so we'll get CH3 CH2 NH2 plus HBr. Okay, now here the reaction can further process, and the reason is what? So in this reaction, if we have alkyl bromide, okay, this alkyl bromide is in excess. If this compound is in excess, if Rx is in excess, reaction will continue. Okay, so what happened? This is the product and this is the reactant. Okay, this is in excess, so it will react further. So CH3 CH2 NH2 plus CH3 CH2 Br. So another hydrogen. Okay, this hydrogen will be replaced. So CH3 CH2 whole twice NH and HBr. Then again we have one more hydrogen, so it will again react. So what will happen here? CH3 CH2 whole twice NH plus CH3 CH2 Br. So this will give you CH3 CH2 whole thrice N and HBr. Okay, so this is the primary amine, this is secondary amine, and this is the tertiary amine. Okay, this one is the primary amine 1 degree, this is the secondary amine, and this is the tertiary amine. Well, it can also form quaternary ammonium salt. Okay, so this reaction will further, because this nitrogen has a lone pair, so this lone pair can form a salt. So let's start the further reaction. CH3 CH2N, I'm writing this lone pair here, and then CH3 CH2 Br. Okay, so what we'll get, we'll get CH3 CH2, and it is a quaternary ammonium salt. So here we'll get tetra N plus and Br minus. So this is a tetraethyl ammonium bromide. This is what tetraethyl tetraethyl ammonium bromide. Okay, so this is what the beauty of this reaction, that if we have alkyl halide is in excess, this reaction will proceed further. So the name of this reaction, is called Hoffman ammonolysis reaction. This is Hoffman Hoffman ammonolysis ammonolysis reaction. Okay, so we had discussed two name reaction. One is the Williamson synthesis, where the formation of ether occurs, and here the because of presence of excess of alkyl halide, the reaction with amino group will continue till we will get the tetraethyl ammonium bromide, or what we can say that the quaternary ammonium salt. Okay, so this is the third reaction. Next we are going to move for the interesting reaction. Okay, this is very interesting, which is coming to you, and conceptual as well, so do take care of this. So this is the page number one, and then we have page number 2. Okay, so this reaction number 4, substitution by nitrite group. Substitution by nitrite group. This, okay, so the substitution by nitrite group, what will it give? It will give formation of nitrite, formation of nitrite. Okay, so let's start the general equation first. The general equation is Rx with nitrite. See, there is two things. One is nitrite and other one is nitrate. So I'm talking about nitrite. So you can take any nitrite. Let's talk. Let's say potassium nitrite. So potassium nitrite is KNO2. If you write, you can write like this, but this is not the correct representation of potassium nitrite. Okay, potassium nitrate, this is not correct representation. So what is the correct representation? That the K is in plus charge, and this oxygen, the N double bond O, and this is another O. Okay, so this oxygen is a negatively charged, so this potassium is directly linked with this oxygen. Okay, this is very important to understand. So what will happen, this will give you this reaction, this plus and this is minus. Okay, so what we'll get, we will get R, and this R will now combine with O and double bond O plus Kx. This is very important to understand. Okay, so let's take an example. CH3 CH2 Br, then KONO plus and minus. So this will give CH3 CH2 ONO plus KBr. Okay, so this is ethyl nitrite. This is what? Ethyl nitrite. Now what is the important thing to understand? The important thing to understand is that here the alkyl, the bond between what? The bond between K and O. The bond between K and O. Okay, that is the KO. This is ionic bond. This is what? Ionic bond. This is ionic bond. Okay, therefore the negative charge on oxygen atom is what? A taking site. Therefore negative charge of oxygen, this I am talking, this oxygen, negative charge oxygen is a taking site. A taking site. So this you need to understand. This is a what? This is a ionic bond. Okay, now moving ahead, the next reaction, and which is very much relevant with this reaction, that is why I'm saying that it is very important reaction. So number 5, here we are going to discuss about the substitution by nitro group. This is the nitrite. Here I'm talking about substitution by nitro group. Okay, here the substitution is what? Nitro group. And what is the product? So product is formation of nitroalkane. Formation of nitroalkane. Okay, so this is very important. Again I'm repeating here, the what was the product? Ethyl and nitrite. Here nitroalkane. Let's see the difference. So again we have a general reaction first. So let's talk about the general reaction. Again we have Rx, and here we require a nitrite. Okay, this is also nitrite, but here this, what is the difference? Here the incoming taking reagent with oxygen. Okay, and here what is happen if we have silver nitrite AgNO2. AgNO2. So AgNO2. Now this will give you simple, and we'll get R. Here you can see that R and double bond O, and oxygen is bonded coordination bond with AgX. So let's just see the difference. Here R is bonded with nitrogen, and here R is bonded with oxygen. So this is the difference between these two. So this is what? This is nitroalkane. This is nitroalkane. That means here the silver, let's take an example of CS3 CH2 Br plus AgNO2. This is the structure. Okay, this will form AgBr, and this is the plus charge, and this is the minus 1, 1 2 3 4. Okay, so this will certainly give you what? CH3 CH2 N double bond O, oxygen plus AgBr. So here what information we'll get? This is the nitroethane, 2 carbon. So this is what? This is nitroethane. Okay, now what is important here? The bond between K and O is ionic. Here the bond between Ag and what? If you are saying that Ag, here the bond is covalent. The bond the bond between this is the bond between Ag and O is covalent. Not Ag only, this is N and O. Okay, this I need to check whether. Okay, so the bond between Ag and O is covalent. Hence, the nucleophilic attack occurs through lone pair of nitrogen here. This. Hence, nucleophilic attack occurs through lone pair of nitrogen. This. So I think we need to draw the structural formula of silver nitrate again. Okay, this is correct actually, but you know this is like this in this way. AgO and double bond O, just like this one I had. So this bond is what? Covalent bond. Okay, and if you go for more deeper study, if you write the electronic configuration, this is a complete electronic configuration. Okay, the inert gas electronic configuration, but in this case the potassium has not inert gas electronic configuration, so there is a polarity. Here we have a complete electronic configuration of inert gases. So according to Fazan rule, this bond become a covalent bond. Okay, so this is the lone pair which is responsible to combine with this side. So these two reactions are very important. I am again repeating that one is the substitution by nitrite group and other one is substitution by nitro group. uh, you might be knowing that the nitrite N and a nitrite O means the attacking site is oxygen here, so this is nitrite O, and attacking site is nitrogen here, so this is nitrite N. This you may learn in coordination chemistry. Okay, but for this discussion it is enough that one is the ionic bond and other one is the covalent bond. Okay, let's go for the next reaction. So the sixth one I'm writing. The sixth one, I think the sketch pen is, see, this is the lockdown period now, so I'm not getting any stationery shop. Okay, so substitution by carboxyl group. Substitution by carboxyl group. Substitution. So what is the product here? Formation of product, formation of ester, formation of ester. So this is very simple reaction. Let's write the general equation first. So general equation. In general equation we have Rx, then we'll take the salt of any carboxylic acid. Okay, because carboxylic acid cannot directly combine, that is why we need salt of that. So this is the salt. Okay, RC silver salt, and in presence we required alcohol. In presence, because water we cannot take, metal is very reactive, so this will substitute, and R C double bond O R plus AgX. Okay, so this is the product, And if you go for the equation example, CH3 CH2Br CH3 COOAg, and this will give you CH3 CH2 COO CH3 plus AgBr. Okay. Okay, now the last, not last, probably the second last. So last reaction, second last reaction, number 7, substitution by hydrosulfide group. These are very simple. Okay, we can leave it also. Let's do some other substitution by mercaptide group. This is an interesting one. Okay, so substitution by mercaptide, MERCAPTID, mercaptide. This is very new one, I think. Okay, and what we will get here, so formation of thioalcohol, no, formation of thioether. Mercaptide is thioether. Formation of, you know that ethers, so this is thioether. Okay, so let's talk about this reaction. So first we'll go for the general equation. The general equation is Rx. Then we required mercaptide. So mercaptide, the formula is NaSr dash. This is called sodium mercaptide. This is sodium mercaptide. And again this will remove out, substitute. So what will get? RSR dash and NaX. So this ROR is ether and RSR is what? Thioether. Thioether. Okay, you can take example. CS3 CH2 Br NaS CH2 CH3 you can take. So what will we get? We get CH3 CH2S CH2 CH3 plus NaBr. And what is the name? This was thioether. This will be diethyl thioether. We have two ethyl group, so diethyl thioether. So this is the end of 7th reaction. These all are the examples of nucleophilic substitution reaction. This is the examples we are discussing here. So now we have one more example, and that is again very important in terms of some conceptual understanding. Okay, like in this case we have some conceptual understanding about the bond formation. Okay, so let's start the discussion of that reaction. That is again very important as far as the conceptual understanding is concerned. Okay, so this is the page number 3. The reaction is 8th one, the substitution by cyano group. Substitution by cyano group. Substitution by cyano group. Cyano, that means what? That is CN. Okay, cyano group, that is called nitrile actually. IUPAC nomenclature. So formation of what? Cyanide or nitrile. Formation of nitrile or cyanide. Okay, so first the general equation. The general equation I'm writing here is Rx. Then we required a cyano group, so let's take an example of KCN, sodium cyanide. And what it will give, this will release KX, and what will get? RC triple bond N and KX. Okay, so this is the general equation. Now let's discuss it in more detail. So if we have alkyl halide, okay, so we have alkyl halide like CS3I, like an example of CS3I, and this is reacting with KCN. So what we'll get? We'll get CS3CN by removal of Ki. Now this can further reduce. Okay, alkyl cyanide can be further converted into different things by in different condition. There are different conditions. So what are that condition? So we'll discuss that condition here. So first we have if we have uh, what concentrated HCl or alkali H2O2. If we have concentrated HCl and or alkali H2O2, we'll get CH3CONH2. This is what? This is acetamide. Acetamide. Okay. Then we have a second choice. If we have dilute HCl or NaOH, dilute HCl or NaOH, so we'll get CH3COOH. That is what? Acetic acid. That is acetic acid. And we have third choice also. So third choice is if we have what sodium plus alcohol. So this sodium alcohol combination will give you hydrogen, Nuskin hydrogen, or we have lithium aluminum AH4, or we can take Ni nickel with hydrogen. So any choice you can take. So what it will give? This will give CH3 CH2 NH2. This is what? Ethylamine. This is ethylamine. That is why I'm saying this is very important reaction. So at a different condition we will get a different product. Now what are these conditions? So first, when we have a concentrated HCl and H2O2, or H2O2 alkaline medium, this is called hydrolysis. This is hydrolysis. So this is what? This is partial hydrolysis. This is partial hydrolysis. So this is not a complete hydrolysis. This is partial hydrolysis. So partial hydrolysis will give you amide. This is complete hydrolysis. The second one, hydrolysis with dilute acid or alkali. This will give you complete hydrolysis. So complete hydrolysis. Hydrolysis is a process which we can carry out by both medium, acidic or basic medium. Both medium we can carry out. This we will study in detail when we discuss about the alcohols reaction. Okay. So this is the complete hydrolysis, and this is what? This is the reduction. This is reduction. Okay, because we here these are the reducing agents. So this reaction is what? Reduction. So these three things you need to understand. One is the partial hydrolysis, which will give you amide. The complete hydrolysis will give you carboxylic acid, and the reduction will give you amine. Okay, so if this reduction is carried out by this reduction process, the reduction process is a name reaction. Actually this reduction process is a name reaction. Okay, when this reduction process is carried out by sodium and alcohol, that means the first one, this is sodium and alcohol. This is called Mendius reaction. So I am writing here, this is Mendius reaction. Okay, when this reduction is process carried out with this. So this is from the cyanide part, the substitution by cyano group. Now moving ahead, the last reaction. This is last one, okay, because the video is getting longer, but I have to complete this. These are very small reactions, that is why I'm taking in a single video only. So this is the last reaction, substitution by isocyanide group. Okay, so next is substitution by isocyanide group. Okay, so what is the product? And here the formation of isocyanide, like here the formation of cyanide, so there is the formation of isocyanide. Okay, so let's talk about this reaction. The first is the general equation. So general equation is Rx, then AgCN. Okay, Rx and AgCN, and this will remove out, and this will give you RNC plus AgX. Okay, this will give you RNC plus AgX. So you can take an example also. If we have CS3, CH2, Br and AgCN, what will get? We'll get CS3 CH2 NC plus AgBr. Okay, this is called ethyl isocyanide. This is called ethyl isocyanide. Now, why I'm saying that is very important. Just look this product with potassium cyanide. The product is cyanide, okay, methyl cyanide. But with silver cyanide, this is isocyanide. Reason is what? So with this we have ended this lecture, and ended this lecture by putting a question to you, that the fourth number, let's take the question, because it is necessary to understand the concept also. So my question is question number one. uh, alkyl halide give cyanide with KCN, but isocyanide with AgCN. Explain. So I think you have a little bit hint in the nitrite, where is covalent and ionic bond, but I am saying that you just think beyond that also. Okay, don't stick to your imagination to that only, just go beyond that. So this is the question for you. And can we put one more question? Yes, we can take one more question. So this is the space I'm leaving for the solution, and this is the question number 2. RCl hydrolyzed to ROH slowly, but the reaction is rapid. The reaction is rapid if catalytic amount of Ki is added. If catalytic amount of Ki is added, this need to be explained. So these two questions you have to solve and send your answer WhatsApp to my WhatsApp number, or uh, just tell me the reaction, what are your reaction about this video, and please mention comment if you think that there is missing something or there is something which we need to review again, any mistake or anything. Okay, please put your comment. So this with this thank you so much for your watching.